So this is just a quick little mini lesson. You can take your own page of notes on it. It's pretty basic. We're not really even going to be writing much on the left. We'll just kind of take some notes about it. So this is called rational exponents. And if you end up wanting to look at it in the book, it's on page 492. It's not in an actual lesson. And what you're looking at is something like this. If you have 16 to the 1/4 power, so we have a fraction in our exponent, what you're actually looking at here is you're looking at what this means is that we have 16 and we're looking at the root here so it's the 4th. So the 4th power of 16. And that whole answer to the 1st power, which isn't going to change our answer in this case because it's just to the 1st power. So now what you have to do is we've been taking square roots and we've been taking cubed roots. Now you're looking at the 4th root. So you have to figure out what number times itself 4 times gives you 16. And if you stop and think about it for a minute, that was 2. So we have 2 to the 1st power, which equals 2. So with these, what's going to happen is the numerator of your exponent, this is only when the exponent's a fraction. The numerator is basically your power, what you're going to raise it to. And then the denominator is the radicand part, what root you're going to take. So numerator is the power. Denominator is the radicand, or the radical. Or the root. Could be the other way you think about it. So let's look at another one where we don't have a 1 here. What we have here is 8 to the 2/3 power. So it looks really confusing, but if you just stop and rewrite it, you're going to have to memorize which one goes with which. It's 8 cubed root. So I have the cubed root of 8. What times itself 3 times gives me 8. But then once I get that answer, I'm actually going to square it. So what times itself 3 times gives you 8? It's 2, and then you're going to square that answer, so 2 squared is 4. So you just have to get used to memorizing that becomes your root, numerator becomes your power after you take your root. And then some of these get a little tougher. So like if we look at this one right here, x to the 3/4 power to the 5th times y to the 1/2 power times y to the 2/5 power. Okay, so this gets pretty much as difficult as you can find them, but you're just going to use the rules that you've already learned. So I know that I need to multiply 5 times 3/4. This is a little bit different than if 3/4 was a fraction, not an exponent. All you're doing is multiplying 5 times 3/4. You're not distributing the 5th power to each of these, because this isn't a fraction, it's just an exponent, and the rule is multiply. So I have x to the 15/4. This one I have like bases, so I'm actually going to add these two exponents, not multiply. So I end up with times y to the 1/2 plus 2/5. And we don't have a common denominator here, so you're going to need to find a common denominator. And you would find that common denominator just like you do with regular fractions. So what's our common denominator? It's 10. So we're going to multiply this fraction by 5 over 5, and we're going to multiply this fraction by 2 over 2. And when we do that, we end up with x to the 15 over 4 times y to the, this one becomes 5 over 10. 1 times 5 is 5, 2 times 5 is 10, plus this one we're multiplying by 2. 2 times 2 is 4, 5 times 2 is 10. Now we have common denominator in our exponent fraction there. So we bring down x to the 15 over 4 times y to the, you add your fractions, 5 plus 4 is 9 over 10. And these you're not going to simplify any further because you don't know what y is, so you can't find the root or square it at this point. So that is your simplified answer of that. So it's just kind of showing you how you would multiply exponents and how you would add them. So that's our little mini lesson. Now we're going to move on to lesson 10.2, which is the Pythagorean theorem. Okay, this is lesson 10.2. The Pythagorean, which is always a fun one to spell, theorem. And you guys all know this already, so if you know it, say it. And hopefully you all said a squared plus b squared equals c squared, and hopefully you all know it has to do with what kind of triangle? The right triangles. So this only works for right triangles. Every great once in a while you'll find a triangle that it works for that's not a right triangle, but you can't count on that happening every time. So you really only want to use this when you see right triangles. And most of you probably remember, if we're looking at a right triangle, we have something called the legs. The legs are referred to as the A side and the B side. Those are ones that form the right angle. So these are the two that actually touch at the right angle. And then the hypotenuse is your C. And the hypotenuse is always across from the right angle. And it's always your longest side. Even if it doesn't look longer in a picture, it always has to be the longest side. So if I had a right triangle, there's my right angle. So I can call this side my A, this side my B. They're the ones that form the right triangle. These can be reversed. Someone else might say this is A and that's B. It doesn't matter. But always across from that is your C, no matter what. Okay, so let's start some examples. Example 1. What is the length of the missing side? And the triangle that they give us here has 9 centimeters and 12 centimeters. So the first thing that you want to do is you want to go through and you want to label your sides. So what do you want to call this side? You could have called it A or B, it doesn't matter. I'm going to go ahead and call this side A. If I called this A, I need to call this one B. If you called that one B, you want to call this one A. And then always the one across is C. So in this case, we are missing our C side. So now you're just going to plug the values in and solve for the missing side. So we have a squared plus b squared equals c squared. So a squared is 9. So we have 9 squared plus 12 squared equals c squared. Don't forget your squared here. And now you just simplify and then solve. So 9 squared is 81. 12 squared, 144, equals c squared. So now you add 81 plus 144, and you get 225 equals c squared. And now from our previous chapter, you know how to solve this. How are you going to get c from c squared? You're going to take the square root of both sides. Okay, in the previous chapter, you learned that when you took the square root of both sides, you needed to put a plus or a minus in front of the side without the variable. But if you stop and think about this, we're looking for a distance, for a length. So are you going to have a negative value here? You're not even going to have the negative value, so you don't even have to worry about the plus or minus, because you already know it's not going to work. And then the square root of 225 is 15. It was a perfect square. 15 equals c. It's not always going to be a perfect square. Sometimes you're going to have to simplify these using what you learned in the last lesson, in lesson 10.1. So in this case, the missing side is 15 centimeters long. Okay, so we're going to go add over here what we just did. So you're going to plug in given values or given sides. And solve for the missing side. The biggest mistake made on Pythagorean theorem is to forget a squared in there somewhere, especially when solving. So always make sure everything is squared. You're going to take square root of both sides. To get the variable. From x squared to x. Okay, it might be a different variable, but basically each time. And then just remember what we talked about up there. You don't need the plus or minus because you won't have negative distances. So we're not asking for possible values of a quadratic like we were in chapter 9. We're actually looking at real-life application with something that's not going to have a negative value. Okay, let's look at example 2. Example 2 is actually a word problem. And I'm going to shorten it, but they give us a picture, so I'll draw the picture. And the question that goes with it is, how high is the top of the ladder from the ground? And there's this picture in your book on page 494 that you might want to look at later, because it's actually a real picture. It looks similar to the one I'm going to draw. So there's a building. One in the picture is a lot better building. And there's a fire, and there's a fire truck. It comes to pull up to the side of the building. It's one of the fire trucks with the ladders. And it says a fire truck parks beside a building such that the base of the ladder is 16 feet from the building. The fire truck extends its ladder 30 feet as shown at the left, which is in the picture. How high is the top of the ladder above the ground? So if we stop and think about this picture, what we've got is a fire truck that's pulled up right here next to, we'll just do this, fire truck that's pulled up right next to the building. And what they're saying is that this fire truck, the base of the fire truck, is 16 feet right there, away from the building. So that's 16 feet. And then they're saying the ladder is going to extend 30 feet from that base. And now they want to know how far the top of this ladder is from the ground. So what do we have missing in this that we're going to have to think about at the end? If I go read it again, it says, it parks at the base of the building. Ladder is 16 feet from the building. And then it says it extends the ladder 30 feet up. And then it also shows in the picture that the fire truck from here to here, right there, is 10 feet. So what are you going to have to do to your final answer once you find the length of this side right here? You should have to add 10 feet to it. So now you need to look at your sides and decide which side is missing. Your right angle is right here. So it's either your A or your B that's missing. It's up to you. I'm going to go ahead and say it's my A that's missing. So I have A squared is missing, plus B squared, which is 16, equals C squared, which is 30. So now I'm just going to go ahead and use my calculator if I need to for some of these. So I have A squared plus 256 equals 900. And now I'm going to solve for A. And when I go to solve for A, I need to subtract 256 from both sides. Now I have A squared equals 644. And then in order to get just A, I need to take the square root of both sides. And I don't know that 644 is a perfect square, so I'm just going to go ahead and grab my calculator, put in 644, take the square root, and I'm going to round it, and it said to round to the nearest tenth. So I have A is approximately 25.4. So now I have my A side is 25.4, but I need to add that 10 still, the 10 feet for how high it started. So now add the 10 feet from the ground to the ladder. So you're going to have 25.4 plus 10, which is 35.4. So your final answer, since it's a word problem, would be in words, and you would say the ladder is about 35.4 feet up from the ground. And that's your answer. If you need to look at that for another minute, hit pause and look at the picture again and look at how it worked. And then we're going to move on to example. Okay, example 3 says, determine whether the given lengths can be sides of a right triangle. So what they're going to do with these is they're actually going to give you 3 sides. They're going to give you an A, a B, and a C. And then they're going to say, okay, take A, B, and C, plug it in, figure out if it actually equals and works out. If it's equal, it's going to be true. If it's not equal, not true. So you're just going to plug in and evaluate your given values. A squared plus B squared equals C squared. Okay, they're not always going to tell you, but remember, C squared is always the longest. So a lot of times you're going to have to actually go find which one C is. They're not going to say C is this one. If the equation balances, then it is a right triangle. Okay, if it doesn't balance, it's not a right triangle. So, for example, if I got something like 6 equals 6 at the end, then that is a right triangle. But if I had something like 6 equals 4, then no, it's not. It didn't balance out. So A squared plus B squared wasn't equal to C squared. So let's try a couple of these. This is the first one they give us. They give us 5 inches, 12 inches, and 13 inches. So first thing you need to do is you just need to go determine which one is your C. So is C 5, 12, or 13? You should have said it was 13. So that's your C. This can be A and B, or this can be A and B, doesn't matter. So I'm just going to go in order with those. So if I have A squared plus B squared equals C squared, I'm going to have 5 squared plus 12 squared equals C squared, which is 13. Sorry about that. 13 squared. That's a 13. So 5 squared is 25, plus 12 squared is 144, equals 13 squared is 169. I just multiplied each of those out. And then when I add 144 plus 25, I get 169. And I had 169 on the right. Does 169 equal 169? Yes. So it's true. And when it's true, that means it is a right triangle. So the way that you would answer this question is, this is a right triangle. Okay, let's look at one other one. So the sides given on this one are 12 meters, 7 meters, and 9 meters. So again, you need to go figure out which one your C is first. You're looking for the longest. So 12 should have been your C. So now A squared plus B squared equals C squared. So 7 squared plus 9 squared equals 12 squared. 7 squared is 49, plus 9 squared is 81, equals 144. And when I add 49 plus 81, I get 130. Does 130 equal 144? You should have said no. It doesn't equal it. No, it's not true. And so that means this is not a right triangle. So this is not a right triangle. Or you could say these sides do not form a right triangle, as long as you say something about it not being a right triangle. So that's the end of the Pythagorean theorem lesson. Tomorrow during class we'll be working on practicing this and answering any questions you have.